So, hello everyone. My name is Vláďa. I work as a software engineer here at Apify. We are really happy to host the PyData meetup, and I would like to today I would like to tell you something about how we can deal with the web scraping challenges in Python. But before we get to the technical part, let me ask you something. Who here uses Google Search? Raise your hand, please. And who uses ChatGPT or other LLM? All right, so pretty much all of us, right? And why am I asking? Because both of these tools heavily rely on the web scraping. Google has to crawler the websites to be able to build its search index, and LLMs like ChatGPT are trained mostly on the public data from the web. So it's not a niche, maybe even shady thing for the hackers, but it's a foundation to the technology we use every day. And now, what is actually web scraping? Most people would answer something like automated extraction of data from the websites, and probably imagine writing CSS or XPath selectors navigating you through the HTML. And you are correct, but not exactly, because this is just a small part of the story. The data extraction is the easy part. The main challenge is to get access to the website in the first place, to convince the web server to provide you the content. Because websites don't like being scraped, and they will try to make it hard for you as possible, because they prefer to be accessed by humans via browsers and not by the scripts. So let's build a scraper together from scratch, and we will see what problems we will encounter. We're going to use a mock-up of an e-commerce website, because I don't want to give you a tutorial on how to scrape a specific real website. The goal is to show you some general techniques and approaches that you can apply to scrape anything. So let's begin. What do we need to start scraping? First thing is something that will handle the HTTP communication for us. In Python, we got many options: requests, HTTPX, AIO HTTP. I believe you know these tools. And we also need something that will parse the HTML for us. Again, Python gives us several options: Beautiful Soup, Parcel, or just more low-level LXML. So let's pick one of these tools and start building a scraper. I'm going to choose, for example, HTTPX with Parcel, install them, and start with a simple script. Really just fetching the website and parsing it with the parcel. Now let's inspect the website we want to scrape. We're going to use developer tools in our browser. And let's say for now, for the beginning, we will extract the product title and its price of a single item of a single headphones on the website. Now let's update the script. Let's update the script to contain the selectors, and we're gonna print the results. So that's it. Let's execute it. And well, 403 forbidden, and some small HTML code saying that the access was denied. What could have happened? One very common reason is IP blocking. Either because of some geographical restrictions, the website owner don't want to provide content to our location, or we host our scraper in a cloud, and the website owner restricts traffic from these IP ranges because they are often associated with bots. Or we just sent too many requests in a short period of time, and we were rate limited. It doesn't necessarily mean that we wanted to spam and overwhelm the server, but maybe just while developing or testing our scraper, we accidentally sent too many requests. Well, so this is a well-known problem. With a simple solution, we're going to use a proxy. So let's update our script to contain a to contain a URI to our proxy server and pass it to the HTTPX GET method. Let's execute it, and well, we're still blocked. Now the error message said that this request has been blocked because it appears to be automated traffic. So we've been recognized as a bot, as automated traffic, and been blocked. So let's inspect the request we are sending, and let's see whether there is something suspicious about them. Here's the example of comparison of the headers from the HTTPX and the headers from a browser, Chrome. And at the first glance, there's quite a difference, right? We are missing a lot of headers. And on top of that, if we focus on the user agent, we are basically confessing that we are accessing the web with Python and even with HTTPX. So our request looks nothing like a request from a browser. So let's try to resolve it, right? We can use the headers from a browser, inject them to our HTTPX request, and let's see, maybe it will help. So we just define our headers in a dictionary and pass it there. The rest code is the same. Now let's execute it. And well, we still don't have the content, but maybe we are not blocked right ahead, and instead we got an HTTP code 402 with a temporary redirection to a CAPTCHA challenge page. So yeah, we are not blocked right ahead, but still we don't have the content we wanted. And since we cannot resolve the CAPTCHA challenge from a script, we're gonna continue with our investigation. So our manual naive approach by patching the headers didn't work, so we will have to dive deeper into these anti-scraping systems. Basically, the thing is that the servers try to collect as many information as possible about us, about our browser, about our device. They compute fingerprints from them and compare them to a well-known profiles of browsers. And based on the similarity, they decide whether we are likely a bot or a human. So let's see what they collect and how they do it. It starts even on the TLS layer. After TCP handshake, our client sends a TLS client hello message to establish an encrypted connection. And even this message contains some interesting information about our client. Specifically, which cipher suites, which signature algorithms, TLS extensions, and compression methods our client supports. And if we look at this table, we might notice that the number of these, let's say, TLS features supported in Python are really different than the ones from the browsers. And when I say Python, what I mean by that? I mean the standard SSL module, which is used by all the HTTP clients I've showed you at the beginning. So it really doesn't matter which one we will use. It will end up the same for all of them. Then on the HTTP layer, of course, the server knows on which version of HTTP we are communicating. For example, HTTPX uses by default HTTP v1.1, but all the current browsers uses version at least 2 or newer. And then the header string, as I showed you before, missing extra headers, but also different ordering of them or casing. Maybe our HTTP client just orders them differently than the browser, and it's again something that could be suspicious. On the JS layer, well, it's the website injects some additional JS code snippets into the content that is being sent to us and is being executed on our device. And thanks to that, they can collect more information about our browser and device. And even on the behavior level, the website, through some interactive elements, can record how we behave on the website, like how we move with the mouse, how we click, how we scroll, how we type, and more. So how can we deal with all of that, right? It sounds like a difficult task. And luckily, we don't have to do it from scratch. There are already tools that are resolving this. So we can use something called browser-like or stealth HTTP clients that tries to mimic the browser's behavior so that they are not recognizable. One of such client is Impit. It's built at Apify. It's fully open source, written in Rust, and ported to JavaScript and Python. Why in Rust? Because as I said earlier in the table, we have to go deeper, or we have to go to some more low-level technologies, because in Python we cannot configure these. So let's update our scraper to use Impit. It has the same interface as HTTPX, so all we have to do is basically just string replace the HTTPX with Impit. Let's execute it, and wow, now there is no block, no error, but also no data. And if we inspect the page, let's say we're just gonna print it, we will notice that the HTML doesn't look like the HTML when we inspect the website through browser developer tools. It doesn't contain the data we wanted. It contains just some placeholders and scripts that needed to be executed so that we got the content we want. So what can we do about that? We got two options. The first one is to reverse engineer the API and call it directly, completely bypass the front end. And it's a good way to go, but basically it's a topic for another talk, so we're not gonna go this way. And instead, we're gonna utilize a real browser that will execute the JavaScript for us. Again, we don't have to write from scratch the process of manipulation with a browser, the process of navigation. We can use browser automation tools. One of them is called Playwright. So, and yeah, it has a port to Python. So let's install it and use it in our script. So now it looks like this. Instead of Impit, we are using Playwright. It's a little bit longer because we have to launch a browser, open the website, fetch its content, and then provide it to the parcel. We are still using parcel for the data extraction, so the selectors and the rest of the code is the same. Now let's try to execute it, and well, it seems we are back where we were. Again, we are detected and blocked. So let's try to inspect the HTTP request we are sending again. And we will notice that in the user agent is this headless flag. So basically, Playwright, similarly as the HTTPX, identifies browsers it manages. So what about that? Just like with HTTP clients, we're going to use something that is intended for the web scraping. There are some Playwright stealth packages that try to resolve this. So let's install package playwright-stealth, update our scraper to just contain one more class, and we can execute it. And finally, we have the data, which is great. But up until now, we've been building everything manually. We've been utilizing HTTP clients, parsers, browser automation, providing proxies to them. But these challenges are not new, right? So maybe we can utilize some existing solution, a more high-level solution, some web scraping library. And one of these libraries is Crawlee. Again, it's being built at Apify. It's fully open source. We got JavaScript and Python implementations. So we're going to use the Python one today. And OK, let's do it. Let's install it and try to update our script to use Crawlee. And let's see what the difference will be. So yes, just starting with the imports, we're going to import a parcel crawler, which, as the name suggests, uses the parcel parser again as before. So we will not have to update our selectors. And crawlers are core components of the Crawlee. It handles all the HTTP communication, configuration, scaling, and everything. And by default, it uses impit. But this interface or this component is fully configurable. So if you want to use other HTTP client, it is possible. Then we will define our request handler, which is the place where all the data extraction is happening. It's so yeah, this is the user's code. It's the same as before. And we're going to register the handler to the crawler via a decorator. And then the last command, crawler run, which is just an execution of the whole process with the list of starting URLs. For our case, it's just one to the list of our eShop. So now let's utilize proxies. One more import from Crawlee, proxy configuration, providing the URI to our proxy and passing it to the crawler. Pretty simple. And now if we want to switch to a browser, instead of parser crawler, we will import playwright crawler. And in the request handler, we will have to do one small update. We will have to at first fetch the content and then provide it to a parser so that we can use parser for the data extraction. So up until now, we've been talking only about dodging blocking. How can we get access to the website? But that's definitely not the only challenge in the web scraping. So let me show you on the following example what is there. So if we get back to our scraper that we've been building, we've scraped only one item so far. Only the first one on the basically on the headphones category, only the first product and only its title and its price. But let's say we want to scrape all the headphones, and also not only from the first page, but from all pages. And also on the list of products, there's only the product name and the product price, but maybe we want to scrape more information about it. So we will have to go to a product detail page. And that's the place where we can scrape, for example, reviews or stock availability, description, and more. So we're going to update our script to scrape all the headphones. But before we jump in, just a quick explanation of the concept named request routing. Basically, we want to send a different type of URLs. In our case, the URLs with the product listing and the URLs with the product detail to a different request handlers. So let me show you on an example how it will look like when we're going to scrape all the headphones. So we're going to start with the default handler. And we're going to so this is the place where we will be extracting the links. So we're going to utilize enqueuelinks utility function here. And on its first call, we're going to extract and enqueue to the request storage system of Crawlee, let's say, the links to the next pages based on the selector we provide. So as you can see, there is the selector a.pagination next that is a link to a next page. And on the second call of this enqueuelinks, we're going to extract and enqueue the links to the detail product pages. And we can see here one difference, that here is the label detail, meaning that it will not go to this default handler, but instead it will go to this detail handler, which is the place where we will do the data extraction and yeah, as you can see, we can extract here more data. So let's say I decided to extract also the manufacturer and the stock availability. But up until now, we've been only printing the results. But that's not much useful, right? We probably want to store them somewhere. So let's update our detail handler to call this push data utility function to store the data into the underlying storage. What is this storage? By default, it's just file system. It's just files on your file system with this structure. So just JSON files. And if we want to use something different, maybe a database, it's really easy to switch. We're gonna use SQL storage client, create a new instance of it with the URI to our database, SQLite in this example for simplicity, and pass it to the storage, to the crawler. Then let's execute it. We can see that everything works. And if we inspect the results, we can see that they are in our database. Now, about scaling. We don't want to send our requests one by one, right? We want to run them in parallel to make our scraping faster. But at the same time, we need to be careful not to overload the server. So the concurrency has to be handled responsibly. And Crawlee manages this for us. It automatically adjusts the concurrency level based on how the website responds. So we got the performance, but also we should not overload the server. About request retries, we also don't want to immediately consider all HTTP error codes as unsuccessful requests, because the website might be temporarily unavailable. There might be network errors, and we maybe want to retry these cases. And again, Crawlee does that automatically. As you can see on the log from one of these runs, the request was tried many times before it fails definitely. And now, when our scraper is ready, we might want to deploy it somewhere. Why should we do it? Maybe we want to call the scraper via API. We want to schedule its runs. We want to monitor its performance, receive alerts when something goes wrong, or integrate it with other services, ETL platforms, or automation tools. So where are we gonna deploy it? The natural home for Crawlee projects is Apify platform. It provides everything we mentioned, and it's easy to use. So let's try it. All we have to do is to install Apify SDK and update our scraper to import this actor class and use it as a context manager actor, because scrapers on the Apify platform are being called actors. And then use Apify CLI to build and push scraper there. So now our scraper lives on the Apify platform. We can execute it, schedule it, inspect the logging, check out historical runs, and of course everything I said before. And on top of that, if our scraper solves a general problem, meaning it could be useful to other people as well, we can make the scraper public and publish it to the Apify store. We can set our pricing and even earn money from it. Or maybe from opposite direction perspective, if we don't want to write scraper ourselves, we can check out the store and use an existing solution instead. Okay, so let me summarize what we have accomplished here. In approximately 45 lines of Python code, we scraped all product data, or all headphones, from a dynamic and well-protected e-commerce site. We could focus only on the data extraction, or mostly on the data extraction, and Crawlee handled the rest for us. The proxy management, retries, browser automation, the request routing, scaling, and also storing the results. And before we finish, let me say something about ethics of web scraping, because certainly we don't want to do any harm. So we should, as I already said, we should scale responsibly, try not to overload the servers, because for small sites, the automated traffic might be really a problem. We should also be careful about private and sensitive data. Also, scraping behind logging typically means that we are accepting the terms of conditions. And there's often written that you are not allowed to access the website via automated tools. And we might consider respect robots.txt, which are guidelines from the website on how the scrapers should behave on the website. Okay, so that's all. Thank you.